Welcome to another video. Today's topic is bounds part 2, truncated measurements. When a measurement is truncated to a given unit, the actual measurements can be up to, but not including, a whole unit bigger but not smaller. Truncating is basically removing a fractional part of the number. In other words, removing the excess of numbers. Here's a number, 0.137892. To truncate this number to the first decimal place, you locate the first decimal place, which is 1, and then you delete the rest of the numbers. And this would equal to 0.1. This is truncation. Same thing if you had, let's say, 0.899999. To truncate this number to, let's say, the first decimal place, you'll do the exact same thing. Look at the first decimal place, which is 8, and then get rid of the rest of the numbers. And that would give you 0.8. It all depends on which unit you are truncating to. So in both of these cases, it was first decimal place, but if it was second decimal place, you'd look at the second decimal place, which here would be 9, and then you'd get rid of the rest of the numbers. Now you will get questions where you will have to find the number or numbers which can be truncated to a number. So in this case, what numbers that represent x can be truncated into 0.1 to the first decimal place? What would x be? Now x would be a range of numbers. Okay, 0.1 truncate to the first decimal place would form 0.1, because 0.1, which has imaginary zeros on the right, you find the first decimal place and then you get rid of the zeros, and that would give you 0.1. So 0.1 truncated to the first decimal place is 0.1, the same thing. Same goes with 0.1 and a bunch of random numbers. Any numbers after the 0.1 will be truncated to 0.1 if it's to the first decimal place. Okay, even if you had 0.1999999, this will be truncated to 0.1 in this case, since it's to the first decimal place. Now if you had 0.2, which is very slightly above 0.199999, this truncated to one decimal place will not equal 0.1. It will be truncated into 0.2. Same with 0.099999. If you truncate this, even though if you truncate this would give you 0. Okay, if you truncate it to the first decimal place, even if it's just slightly below 0.1, okay, it would still be truncated to 0 and not 0.1. So this means that there is a range, okay, between these two numbers. So if you want to find the range in which numbers can be truncated to 0.1 to the first decimal place, you would have 0.1 as the minimum value, so x greater or equal to 0.1, and then smaller than 0.2. Since 0.2 is the cutoff limit for numbers that can be truncated to 0.1 to the first decimal place. So this would be your range of numbers that can be truncated to 0.1 to the first decimal place. Question 1. Truncate 63.830756 to the following units. So to one decimal place, again, you'd look at first decimal place, which is 8, and then you get rid of the rest of the numbers. So this would give you 67.8. Now to 3 decimal place, you would look at the third decimal place, which is 0, and then you simply get rid of the rest of the numbers after, and that would give you 67.830 or 67.83. Now for C, truncate this number to two significant figures. You find the second significant figure, which is 7, and then you get rid of the rest of the numbers. So this would give you 67. Now for question 2, x has been truncated to the first decimal place to form 19.4. So x has been truncated to 19.4 to the first decimal place. What is x? So of course x would be a range, okay, because it's not just one number that can be truncated to 19.4, it's many of them. So to find this range, you write the number itself that has been truncated, and then you find the maximum value which wouldn't be included. So this would be a whole unit greater. Going back to this definition, when a measurement is truncated to a given unit, the actual measurement can be up to, but not including, a whole unit bigger, but not smaller. So using this phrase, go back to the question. So a whole unit bigger would mean 19.4 plus 0.1, since we're doing to the first decimal place. So this would give you 19.5. Going back to the definition, it says, but not including, which is why I didn't put an equal sign under like this. Okay, it's under 19.5, because if you had 19.5, okay, if you had 19.5 and you truncate this to the first decimal place, this would give you 19.5, not 19.4. It wouldn't give you that, which is why this is the cutoff limit. And anything below 19.4, going back to this, anything below 0.1 wouldn't be truncated to 0.1. Same here. Anything below 19.4, so let's say 19.39999, wouldn't be truncated to 19.4. It will be truncated to 19.3. So this would be your answer. A range. Moving on. So question 3. X has been truncated to the second decimal place to form 106.11. What is X? So again, you write out your range, which will look like this. Actually, let me write it nicely. X greater or equal to, and then less. So you would put the truncated form as the minimum. So that would be 106.11. And then you would put the maximum range, which is a unit greater than this. In this case, the unit is 0.01, since it's the second decimal place. So 106.11 plus 0.01 would give you 106.12. So then this would be 106.12. A teacher truncated the class's average score to 810 to two significant figures. What could have been the class's average score exactly? Plot your range, x, and then the greater or equal to, and then the lower than sign. I keep forgetting what these are called. So then you put the initial number, the truncated number, sorry, and then you add 810 with the unit. In this case, the unit is to two significant figures, so 1, 1, 2, so that means 10. Okay, so 1, 2 plus 10, so then this would be 820. Anyways, this was the last question. This can be a bit tricky, but if you do enough questions, then you should be fine. Anyways, thank you guys for watching, and see you in the next video.